Hello students. Okay, so I created this video to help you prepare for the quiz tomorrow, to go through everything we've covered and try to give it in some detail so you can go back, you can rewind, you can see what I'm saying, you can make sure you know all the key concepts. So we began the farthest thing away from what we've done recently. It was 1, 2. We talked about rational numbers. So rational numbers are most numbers you've interacted with in your life. The only kind of number probably that you've seen that's not rational is pi. Pi is special because it goes on forever with no end, and it does not have a repeating pattern. So we can't write pi with that repeating bar over it. So that makes it not rational. It goes on forever without a repeating pattern. But all other numbers you've ever seen are rational numbers. So let's think about what those are. There's 3 types that we talked about. You can follow along with this in your notebook if you can't see very well. So there's integers. Integers are positive. Integers are what we've been dealing with recently. They're positive and negative numbers and 0 that have no decimals or no fractions. No decimals, no fractions. That's our definition of an integer. And all integers are rational numbers. There's also terminating decimals. Remember terminator. Terminating means you end. Terminators destroy, they end things. Terminating decimals are decimals that end or have some finite number of digits. So an example is 2.3, negative 2.1. 48.123. They're all decimals that end. They do not go on forever. All terminating decimals are rational numbers. And then our final type are repeating decimals. So a repeating decimal is a decimal that does go on forever, but it has a repeating sequence of numbers that we can write, and we can ultimately use the repeating bar. So these are 2 examples. 1.23232323 ... Forever, you're going to have 2323. It does not end, but it has that repeating pattern. So we can write it nicely as 1.23. You know me. We can write it nicely as 1.23 with the repeating bar. 1.23 repeated. Another one is this number. We have negative 32.44444444 forever. That's a repeating decimal. Even though it goes on forever, it's repeating the same number or same sequence of numbers. And we can write that as negative 32.4 with our repeating bar. Goes on forever. So these are all of our rational numbers. Integers, terminating decimals, and repeating decimals. If you see a number that has a ... so it goes on forever, and there's not a repeating pattern, then it's not rational. But any other type of number is. So that might be a question you see on the quiz on Friday. You'll see a number, and it'll ask you, is this an integer? Is it a repeating decimal? Is it a terminating decimal? Is it not rational? Is it rational? So you should be able to answer those. So these are the examples, and you had these in your notes, so you should reference those if you need any help. Okay, so that's 1, 2. That's what we started with. Now let's go to 1, 1. The biggest idea in 1, 1 was that integers sum to 0. So that's not something we really have notes for, or that we have to spend that much time talking about. The idea is that if we have negative 2 plus 2, that equals 0. If we have negative 105 plus 105, it equals 0. We could also have the reverse. We could have 123 plus negative 123, order doesn't matter, it's going to equal 0. Because these are pairs of opposites, which means they're the same distance from 0, but they're on opposite sides of the equal sign. So negative 2 and 2 are both 2 away from 0. Remember, generally opposites just mean the number is the same, but the sign is different. So that's the most important thing you need to know from 1-1, that opposites sum to 0. So when we add a positive number with its some number with its opposite, you're going to get 0. If there are any questions on that, be sure to look at your notes, be sure to talk to me. That's the takeaway from 1-1. Then we get into a little harder stuff when we get into 1-3. So this is what we've been doing more of. This is when we're thinking about adding negative numbers. There's lots of different types of these problems. We're going to go through a few of them. So the first type is when we're adding two negative numbers. So if we have negative 4 plus negative 6, we need to figure out what that is. So the first way we can think about it is the whole model, the dirt model. So if I have negative 4 plus negative 6, I'm going to go to my whole drawing. Remember that if it's a hole, if it's a negative number, we can think about that as a hole in the ground. So this is my grass at 0. And I have two holes at the ground at the moment. I have a hole of negative 4, so it goes down 4. And I have a hole of negative 6, it goes down to negative 6. So what I'm going to do, if I'm doing negative 4 plus negative 6, is I'm going to add my holes together. If I add a hole together, I'm going to take my hole here, my other hole here, put them together, negative 4 plus negative 6, and I end up down here at negative 10. So if I have two negative holes that go in the same direction, I'm getting more negative. This is how we can represent it on the number line. Negative 4 plus negative 6. So negative 4 is going to take me down to negative 4. Then if I'm adding a negative 6, that's going to take me down again, 6 spots. And I'll end at negative 10. So that would be the number line model. And then finally, there's what we've been talking about a little bit more recently, which is that if we have two negative numbers, we're going in the same direction, we can take the absolute value of the two numbers, which just means you make them positive. So the absolute value of negative 4 is 4. The absolute value of negative 6 is 6. And then we can add those absolute values together. So then we can do 4 plus 6 equals 10. But in this problem, of course, I don't have 4 plus 6, I have negative 4 plus negative 6. Since they're the same sign and they're both negative, then I can just conclude that negative 4 plus negative 6 equals negative 10. And that's my answer, negative 10. So again, since these were the same sign that I was adding together, I take the absolute values and I add them. Same sign. Okay. Then we have examples where we don't add the same sign. So one of our examples was negative 5 plus 4. This one is different because we don't have two negatives or two positives. We have one negative and one positive, different signs. So for this, we're going to end up doing something different with this shortcut. Let's first go back to the whole model. Negative 5 plus 4 for our whole model. So for our negative 5, That's our hole in the ground that goes 5 deep. Then we have positive 4, right? Positive 4 is going to be our pile of dirt up here above the ground. So for this question, if we're adding our pile of dirt, our positive 4, with our hole that's 5 deep, what's going to happen? Well, I'm going to take my positive 4, put it into my hole, and it's going to fill almost all of the hole. However, there's still 1 unit of a hole still there, because 4 units of dirt will not fill up an entire hole that's 5 units deep. We'll be 1 away from the surface. So that's why we have this -1 that we're left with. So -5 plus 4 is -1. Because we're that far away, we still have that much of a hole, 1 away from 0. So again, one more time, we have our hole that's -5 deep, and our dirt 4 can fill up most of the hole, but there's still 1 left that it can't fill up. There's not enough dirt, not enough positive number. For our number line approach, we can see here, -5 is what's going to go down to get to -5, that's in blue. Then we are adding 4, that's in red. So we stop where we were at -5 and we count up 1, 2, 3, 4. I can do that. You can use the jumps as well. We're at -5. We jump up 1, 2, 3, 4, and we get -1. So -5 plus 4 is -1. That's how far we end up. Okay. So then, if we wanted to not use it with the visual model, which you don't need to, but it's good to be getting towards this, is we see that we have a positive and a negative. We're adding them together, so our rule then is we subtract the absolute values. So we do, the absolute value of -5 is 5. The absolute value of 4 is 4, right? We're just making them positive. Then we do 5 minus 4 is 1. And then we have to figure out the sign. Is it +1 or is it -1? Let's go back to our original numbers. We had a -5 and a +4. Since 5 is bigger than 4, 5 has the power. So since 5 is negative, then this answer is going to end up being -2. So -5 plus 4 is -1. That's our answer. And that was 1, 3. Adding negative numbers, adding integers. And then we added one last step when we got to 1, 4, which was subtracting integers. So for this one, the way we learned it is that we don't actually need to learn a new method. We just need to learn how to rewrite subtraction as addition. So this is the thing I keep having us say in class. And I will write it up here, and it's in your notes 2 times. So the thing we have to remember is that subtraction is the same as adding the, I hope you know it, opposite. Subtraction is the same as adding the opposite. So, if we have 2 minus 3, that is the same as 2 plus -3. It's the same because subtracting +3 means that's going to be the same as adding the opposite of +3. And the opposite of +3 is -3. Then at this point, we can do this just like we did example 2. So I'm not going to go through that again, but you should go back and look at how to do this, because this is just like our example 2 from 1 to 3. Then we can look at example 4. For example 4, we're going to have -2 minus 3. This, again, isn't actually very different, but it is where people start to get confused. So we're just going to rewrite -2, because we're not dealing with that at all. -2 is staying the same. And then we're subtracting 3. So when we subtract 3, subtraction is the same as adding the opposite. So subtracting positive 3 is the same as adding -3. So these two statements are equivalent. -2 minus 3 is the same as -2 plus -3. And then again, you can go back to the last examples for adding and see how we get this answer. And then our most recent thing that we did yesterday for example 5 is when we have something like -2 minus -4. We are subtracting a negative number. So our rule says subtraction is the same as adding the opposite. So I'm going to keep my -2 the same because we're not dealing with that. And then I am subtracting -4. So the same thing as subtracting -4 is going to be adding the opposite of -4. The opposite of -4 is positive 4. So this is the same as adding 4. Conceptually, we talked about how this was like we were trying to get rid of a hole. If we have a hole, that's what our negative number is. It's -4. And trying to subtract -4 means we're trying to get rid of a hole. The only way you get rid of a hole is by adding dirt into the hole. So that's what we're doing here when we're going from minus -4 to plus 4. We are adding 4 units of dirt. And that's going to close the hole. That's going to do what this is saying. The other trick we talked about is if you have a minus, parentheses, negative sign, it kind of looks like a plus sign if you put it together. And that's a trick that can help you remember. If we have this minus, parentheses, negative, whenever we are subtracting a negative, it turns into addition. And then again, -2 plus 4 is like our examples for the addition. So you should go back to the addition if we're stuck there. But all we really learned in 1.4 is how to rewrite subtraction as addition. Okay. So that's everything that's going to be on the test, on the quiz. If you understand this video, if you can do these examples, you're going to be fine. So you should come at lunch, you should come after school, you should send me a message tonight. Remember, I have a teacher Instagram. It is ms.steliotis. So at ms.steliotis. If you have an Instagram and you want to follow it, or if you want to DM me questions as you're studying, I would love to help you. So take advantage of these resources, study, make it a good first quiz, and a good ending of week 3.